Hello, welcome to the new AP Computer Science A series, Unit 2. If you want to jump ahead to a specific topic, check out the time markers in the video description. Also, I will be adding to and updating this series, so make sure to hit the subscribe button to keep up to date on all the latest content. In this Java tutorial, we're going to learn about using Java classes and writing code to create objects from those classes. First, let's talk about what an object is. An object is also known as an instance of a class, and sometimes people refer to an object just as an instance. In object-oriented programming, objects have the following characteristics. They have states, and we represent those with fields in Java, and they have behaviors, and we represent those with methods in Java. Let's look at an example. Let's say we created a light bulb object. So two states might be the color and the wattage. Three behaviors might be turn on, turn off, and flash. Of course, the states would be represented by fields in Java, and the behaviors would be represented by methods. We'll learn more about fields and methods at another point in the course. Now, let's talk about a class that the light bulb object was made from. A class is a blueprint or a template for an object. So there needs to be a class before we create an object. There are a number of classes built into Java, so often we just use these pre-made classes. Here's how we can create an object from the light bulb class. We start by declaring the name of the class, in this case light bulb, then a variable, in this case x, and we say equals new light bulb, open close parentheses, semicolon. So we're creating a variable called x of type light bulb, and it's going to point at a new object in memory of the light bulb type. And there we go, we've got x and the object attached to x. Now let's look at another way to declare and initialize a light bulb object. Here we can declare the light bulb variable y on one line, and then we can initialize it on the next line by saying y equals new light bulb, open close parentheses. And then we get a second object attached to the y variable. Now let's look at another example. Here we're declaring the variable z of type light bulb and setting it equal to a new light bulb. However, what we're doing is we're passing some data to the constructor inside the parentheses. In this case, we're passing the string green. You can do this with some classes where you pass data inside the parentheses that determines what type of object you're creating. So the light bulb attached to the variable z is green in color. It's important to know with a particular object what type of data you can pass inside these parentheses. Next, let's look at this line of code. So we're calling the turnoff method from the y variable. So we're saying y.turnoff open close parentheses. And when we execute this, it changes either the data or the behavior of the object that y is pointing at, and it turned off the light bulb. Now the light bulb was a class that I just wrote for the purpose of this lesson. However, let's look at an existing class in Java. So the math class is a commonly used class in Java. For certain methods in classes, you don't actually have to create an object. You can just call the methods from the class itself. So you can see these examples. Math.abs, which is going to give us the absolute value of whatever we put in here, or Math.round, or Math.square-root, or Math.random, which would give us a random number. Methods that don't need an object and can just be called from the name of the class are called static methods. Methods where you need to create an object first, like the turn-off method in the previous example, those are called non-static methods. What's interesting about the math class is all the methods in the math class are static, so there would never be any reason that you'd need to create an object of the math class. In fact, you can't create an object of the math class. Next, let's discuss some different ways to create objects from classes in Java. The way I demonstrated with the light bulb class is by far the most common. So we'd say the name of the class, name of the variable equals new, then the name of the class, again, open close parentheses. For some classes, you can put data inside the parentheses that determines what type of object you make. There's a few classes out there, there's unique ways that you can create objects. One of them is the string. So the most common way to create a string is to say name of the class, the variable, then set it equal to, and just set a string literal. Also arrays, we'd say the data type of the array, square brackets, the name of the variable, equals new, the data type of the array, and then inside square brackets, how many indexes we want of the array. Here's a second way to create arrays. We can say the data type of the array, square brackets, the name of the variable, then set it equal to a hard-coded array. If you don't understand what's going on with the string and the arrays, that's no problem. I've got other lessons on those topics. I'm just demonstrating to show you there's some unique ways to create objects for certain classes. Okay, there you go. Now you're ready to start using classes and making objects. In this Java tutorial, we're going to be learning about methods. Methods are blocks of code that can be called from another part of the program. If you have a piece of code you're going to use over and over again, it makes sense to put it in a method so you don't have to rewrite it in different parts of your program. Methods may have parameters, which are a type of variable that allow us to pass data to them. Methods may return information to the part of the program that called them. For a method with a void return type, a return statement is optional. However, for a method with any other return type, it must return a piece of data of the correct type. Methods end as soon as they reach a return statement, even if there is more code in the method. Let's start by writing a simple method. We always have to have methods inside a class. However, for the sake of saving space, we're not going to put the class code at the top and the bottom. We start by writing our main method. The main method always has to be written like this: public static void main string args. A main method is the only method that will run automatically when a program is run. Now let's write a second method. This method, public static int. It's int, so that means we have to return a piece of data of int type. I've named it add2nums, and I've given it two parameters, which are a type of variable that allows the method to accept data when it is called. We can use these parameters to customize the behavior of the method. In this case, we're going to add num1 and num2 and put them inside a variable called total. Then we're going to return total. Here is a command that calls the method. We see that this call has two arguments. These arguments get passed to the parameters in the method. The number and type of arguments have to match the number and type of parameters in the method that it is calling. When we call this method and pass the arguments 5 and 3, it's going to add 5 plus 3 together and return the total, which is 8. However, we're not doing anything with the data that's returned, so it just disappears into the ether. It might make sense to do something like this instead. Here, we're taking the data that gets returned and putting it into a new variable called sum that we can use later. Now let's look at another method. This one is to take an average of two numbers. We've named our parameters int num_a and int num_b. We're going to use the add2nums method because if you want to take an average, first you need to add two numbers together. Instead of rewriting the code, I'm just calling add2nums, passing the data that was passed to us here, and then dividing whatever the result of add2numbers by 2 so I have the average. Next, I'm going to create a variable in the main method, avg, and set it equal to a call of the method average of 2 with the two arguments 7 and 5. Now I'm going to write a third method. This method is a void type method, so a return statement is optional. We have one parameter num3, and it's going to print out the string average is, and then concatenate that string with the value in the variable num3. Here, we call the method printAverage and pass it the data inside the variable avg. Avg is not being passed, but the stack data inside avg is. Next, we're going to trace out the code. All these variables are primitive type variables, so the only data will be stored on the stack. You will see variables appearing and disappearing on the stack as they are created and destroyed. You'll also see variables grayed out as they move out of scope and then turn black again as they move back into scope. To understand better how and why this works, click on the link in the upper right-hand corner of the screen to a video called Scope and Lifetime of Variables. We'll start here. We create the variable sum on the stack, and then we call the method add2nums and pass it the arguments 5 and 3. These 5 and 3 get passed to the parameters num1 and num2, and they're created on the stack here. Next, we create the variable total and set it equal to num1 plus num2, 5 plus 3 equals 8. Finally, we return total. Total is 8, so it takes the place of this add2nums 5, 3. Finally, we set the return of 8 equal to sum. Next, we're going to create the variable on the stack, avg, and set it equal to whatever is returned by average of 2 when we pass it the arguments 7 and 5. The variables go to these parameters num a and num b. Next, we have to call add2nums and pass it the 5 and the 7. The 5 and the 7 go into the parameters of add2nums, and we can see it on the stack right here. Next, we create this local variable total, set it equal to num1 plus num2, 7 plus 5 equals 12. Then we return the data inside the variable total, and it goes here. Next, we have to do this division, 12 divided by 2, and that gives us the average, which is 6. Now we'll return that 6 to where it was called. Average will get set to equal 6, and it's placed right here on the stack. Finally, we're going to call the method printAverage and pass it whatever value is inside the variable avg. The number 6 gets passed to the parameter num3, and that gets created on the stack. Next, we call systemoutPrintLine. We concatenate the string literal average is with the data inside the variable num3, so we get average is 6. Some final information on methods. A method can have multiple return statements, but only one is activated every time the method is run. Depending on the flow of the program, one return statement may be used once, and another one may be used another time. You must have the same number, type, and order of arguments as you do for parameters. The arguments must match the parameters. In this Java tutorial, we're going to learn about escape sequences. So what is an escape sequence? It's a way to represent certain special characters inside a string, and we're going to learn what those special characters are in just a minute. Let's take a look at this line of code. SystemoutPrintLine, this is a test message. And the quotes tell the computer that everything inside here is a string. Most IDEs will color code strings, so that way we can easily recognize them in code. We run this, and then it prints out this is a test message. Now let's say instead we wanted to output this is a quote-unquote test message. Well, what we would think to do is just add a quote here or a quote there, and then it should print this out. However, let's look at what happens. The computer interprets this as we're opening a string here, we're closing a string there, then we're opening another string here, then we're closing another string here, and it doesn't even know what this stuff in the middle is. So this is going to give us an error. The way we get around this is that we use an escape sequence to let the computer know we want literally the quote here inside our string, not the quote as an opening or a closing of a new string. In Java, the escape character is a backslash, and you find that right above the enter key. Let's highlight these escape sequences in red. This escape sequence for a quotation mark is going to be backslash quote, and then we're going to do it again backslash quote. Then we're going to get the output we want. This is a test message. Let's look at all the escape sequences in Java. Realistically, the only ones you're going to probably use are these first 4. insert a backslash, insert a new line, insert a double quote, and insert a single quote. And if you're studying for the AP Computer Science A exam, you only need to know these first three. As practice, let's look at this sample bit of code. You can pause right here and try to guess what the output's going to be, and then compare it with the actual answer. To make it a little easier, I'm going to highlight all of the escape sequences in red. Let's see what it'll output. We get ABC. This is the escape sequence for a backslash right there. This is an escape sequence for a single quote. Then we have space DEF. Backslash N is the escape sequence for a new line, so we go down to the next line. Then we have a space, the escape sequence for a double quote right here. Then a space and a GHI. One good way to practice with escape sequences is write some code with an escape sequence, try to guess what's going to be output, and then check your work when you run the program. In this Java tutorial, we're going to learn about the string class. Some important facts to know. Strings are a data type that can hold text. Internally, strings are an array of the primitive type char. The string class has a variety of methods to compare and modify strings. You can look up all the methods in the class online on Oracle's website. Next, we're going to look at two different ways to declare and initialize string variables. Depending on how we do it, Java will handle them differently in memory. The most common way is to say string, the name of the variable, then set it equal to a string literal like this. In this case, Java will place a variable on the stack and have a pointer pointing at the object on the heap. For strings, it will place them inside a string pool. What this means is that if we declare another string with the same value, Java will simply look in the string pool and see that it's already there, and then have that next variable point at the same memory location. This is different behavior than with most other objects, and it serves to save memory. Now let's look at a second way to declare and initialize string variables. Here we're saying string C equals new string hello. This is more like how we declare and initialize most objects. When we do it this way, Java will create a unique object outside of the string pool. If we do it again this way, even though it's the same value, it's going to create a second object on a different part of the heap. Now let's look at this line of code. For the purpose of this lesson, SOP stands for System Out Print Line. We're checking, does A double equals B? With primitive types, this compares the values that are stored on the stack. However, with object types, double equals checks are the variables pointing to the same location on the heap. The values on the heap may be the same, but if they aren't pointing to the same location, this will return false. In this case, A and B are pointing to the same memory location, so it will return true. Now let's compare it to this line of code. We're checking, are C and D, the variables, pointing at the same memory location on the heap? They are not, so this will print out false. Even though the data on the heap is the same, the memory locations where the data is stored is different. Because of this, double equals is not a good way to compare objects. In the case of strings, we prefer to use the dot equals method. So A dot equals B compares the data that A and B are pointing to. So this hello is the same value as this hello, so it will be equal. Now C and D, which are pointing to different memory locations, but the data in those memory locations are the same, so the dot equals method in the string class will compare the actual strings at those memory locations, and it will also print out true. Let's look at another way to use the dot equals method in the string class. Here we say A dot equals the string literal hello. A is pointing at a string that says hello, which is equal to the string literal hello, so this will return and then print out the value true. Next, let's change A. We're saying A equals hola. Strings are what's called immutable, which means we can't change the data on the heap. So if we do something like set a equal to Ola, it's going to create a brand new object, and it's going to move the pointer from a to that new object. Let's look at some other examples to see how strings are handled in memory. Here we're declaring a reference variable e and having it point at a new object hi. Here we're creating a new reference variable of type string f, and we're copying the pointer from e to f so they're pointing at the same memory location. Now what we're doing is we're creating a new reference variable g of type string and setting it equal to the string literal howdy. Next, we're declaring string h and setting it equal to hi with h and I capitalized. Here we're checking, does e dot equals f? E and f are pointing at the same memory location, though for the dot equals method that doesn't matter. What matters is they are both pointing to an object that are equivalent to each other. So this returns and prints out true. Here we're checking e and h. Even though e and h are both pointing at an object that says hi, Java considers different capitalization to be unequal. Here we check e equals ignored case h. So in this case, e and h are equal because if we ignore capitalization issues, these are the same words that they are pointing at. Here we are using the dot length method. The dot length method checks the number of characters in the string that a reference variable is pointing at. So g is pointing at howdy, which is 1, 2, 3, 4, 5 characters. The next method we're going to look at is the substring method. What this does is this takes a part of the string and returns the substring. In the case where we have one argument, it starts at this index and then returns everything from this index to the end. Like arrays, strings are zero indexed. So G is pointing at howdy, index 0, 1, 2. It starts at 2 and goes to the end, so it returns a substring WDY. There's a second version of the substring class that has two parameters, so we need to provide it with two arguments. In this case, the first argument is where we want to start, and the second one is where we want to stop. However, you must be very careful because the first index is inclusive while the second one is exclusive. So we will start at index 1, but we will end one before index 4. So we see G substring, index 1, 2, 3. It does not include index 4. Finally, let's look at the compare to method. What this does is it looks at the strings that h and e are pointing at and converts them to Unicode numerical values. Then it compares it and will return a 0 if they have the same Unicode values, or it will return a positive or negative number. This is very useful if we want to create a sorting algorithm that organizes strings lexicographically. If we want to organize strings alphabetically, it's more useful to use compare to ignore case. Finally, let's look at a couple of examples of how we might use these methods. Here, I'm taking the length of the string h is pointing at, and I'm storing it in an int value I. Here, we are checking if e, which is currently pointing at a string hi, equals the string literal hi. In this case, if this returns true, we are going to have it print out e equals hi to the console. In this Java tutorial, we're going to learn about the math class. Some important facts. First, the math class in Java contains a variety of methods that perform different mathematical functions. Second, all methods in the math class are static. Third, you can't extend or create an instance of the math class. Let's look at this first method, the ABS method in math. You can pass it an int, a double, a float, or a long, and it will return the absolute value of whatever data type you sent. For example, if we send it the double, negative 3.2 in these parentheses, it will return the double, positive 3.2. Next, let's look at Math.POW. We can pass a combination of two ints, doubles, floats, or longs. We can mix and match those primitive types. Math.pow will always return a double regardless of what data type we send it. Here is an example. In this case, we want to take 3 and put it to the power of 2. So we put our base, a comma, and then our exponent. In this case, our base is an int and our exponent is a double, but it wouldn't have to be this way. 3 to the second power will be 9, so it will return the double 9.0. Next, we have math.sqrt. You can pass either an int, a double, a float, or a long. Math.sqrt will always return a double no matter what data type you send it. Let's look at this example. Math.sqrt, and we're sending the argument an int 9, and it will return 3.0 because 3 is the square root of 9. Now let's look at this. This is not actually a method. This is a public variable, so we are actually accessing a variable inside the math class. This is a public variable, so we can access it without a getter method. Math.pi is a double variable that is approximately equal to the mathematical constant pi. For example, the variable circumference equals 2 times math.pi times radius. You will notice that there is no open close parentheses after math.pi. That's because pi is a variable and not a method like the others. Let's look at some other useful methods. There are a number of other methods, and you can see the details of all the methods in the math class by checking the reference document for the math class in Java. In this Java tutorial, we're going to learn how to generate random numbers with the random method in the math class. Some important facts. There are several ways to generate random numbers in Java, one of which is using the random method in the math class. The math class includes many mathematical methods, including the random method. Third, random is a static method, so we can call it without creating an instance of the math class. Math.random will return a value that is greater than or equal to 0.0 and less than 1.0. That means the minimum value it can return is 0.0 and the maximum value is 0.9 repeating. It's important to understand Math.random will never return 1. Let's say we want to generate a random int between 0 and 10 inclusive. We'd start by declaring an int variable, in this case we're calling it randNum, to hold whatever number we calculated. Then we would call math.random and we would multiply that by 11. It's very important to have these parentheses here because we want to make sure we multiply the result of math.random by 11 before we cast it as an int. Let's try this out and see how it would work. So the least value math.random could return would be 0.0. If we multiplied 0.0 times 11, we would get 0.0. Then we would cast 0.0 as an int, which would cut off everything after the decimal point and leave 0. Now let's try it on the other end. The maximum value math.random could return is 0.9 repeating. If we multiplied that by 11, we would get 10.9 repeating. And when we cast that as an int, we would get 10. If math.random were somewhere between 0 and 0.999, we would get a number between 0 and 10. Now let's say we want a number between 1 and 10. We want the minimum value to be 1, so I added a plus 1 at the end. Let's try this out. So, we know math.random times 10 will give us a value between 0 and 9. So, if we add 1 at the end, that's going to end up giving us a value between 1 and 10. Because whatever math.random times 10 is, we're going to add 1 to it. Let's look at some examples of how we might use the math.random method. Let's say we wanted to pick a random name. So we've got an array of strings, called name, and we've got 3 indexes, Dorothy, Glenda, and Toto. First, we're going to generate a random number between 0 and 2 because we've got index 0, 1, and 2. Then, once we had the random number, we would set our string chosen name equal to the name array and whatever random index was chosen. Another example is if we want to simulate the flip of a coin. So in this case, we're going to generate a random number between 0 and 1, and that's going to be stored in the int variable coin flip. If coin flip equals 0, we're going to say it was a heads. If coin flip did not equal 0, we're going to have it output tails. So it'll be a 50-50 chance it's heads, 50-50 chance it's tails. Hello. In this Java tutorial, we are going to learn how to use the scanner class to take input from the user in the console. So the first thing we have to do, even before we create a class, is we have to import the scanner class. We're going to say import java.util.scanner with a capital S. We'll hit a semicolon there. Next, we can create the class like we normally do. So we're going to call this public class user input. Then we'll open and close the class. We're going to create a main method, public static void main string array args. Open and close this. The next thing we need to do is we need to create an instance of the scanner class. So we're going to declare a variable of type scanner. Since scanner is an object type variable, we start it with a capital S. Then we'll call our variable keyboard. People generally call it keyboard or KBD. It doesn't matter, but pick a variable name that makes sense. Now we need to initialize a variable, so we'll say equals new scanner, open close parentheses, system with a capital S .in and end with a semicolon. So we can use this variable, which is pointing at a scanner object, to take input from the console here. We're going to start by learning how to use the scanner object to take input for the 3 primitive types you need to use for the AP Computer Science A course. Those 3 primitives are Boolean, int, and double. So we'll start by declaring a double. We'll call it x, and we'll say equals keyboard dot next double, and then open close parentheses and end with a semicolon. Now when we run it, we're going to notice that it just kind of hangs here. And that's because it's waiting for us to enter in a double before it can continue. So I can enter in a double 12.3, and then it finishes the program. Now generally it makes sense to let the user know what you want. So I'm going to say system out print line, type in your height. So now when I run it, it's going to say type in your height, and it's going to pause to wait for me to type in the next double, and then it's going to finish. So I'm going to say 55.0. And there we go. Now we're going to add some more code. We're going to do this with an int and then with a Boolean. So for an int, it's going to be almost the same. We're going to say int y equals keyboard dot next with a lowercase n, int, open close parentheses. And we also want some text to let the user know what information we want. So we'll say, what is your age? So then when we run it, it's going to first ask us your height. Then it's waiting for us to type in our height. So I'm going to say 55.9. Then it's going to say, what is your age? And it's waiting for us to enter in our age. So I'll say 32 and hit enter, and then it finishes the program. So now we're going to do it with a Boolean. And we're going to say Boolean. Now x and y are bad variable names for this because they don't really explain what the purpose of the variable is. So I'm going to say is female. And then I'm going to say equals keyboard dot next Boolean, open close parentheses. I'm going to say system out print line. I'm going to say are you female? And I'm going to let the user know we want it in true false, because if we enter the wrong data type, it's going to crash the program. So end with a semicolon. I'm going to run it. We're asking height 55, age 21, and are you female? False. All right, the last thing we're going to do is we're going to learn how to take strings in. By the way, for more information on strings, please click on the link in the upper right-hand corner of this screen. So I'm going to say string name, and I'm going to set it equal to keyboard dot next. People expect it's going to be next string, but no, it's dot next. Now this will only take the first word, takes the first word on a line. So if you type several different words separated by a space, it's only going to take the first one. If we wanted to say string like full name and get all the words on the line, we would say keyboard.next line, open close parentheses. The thing to be careful about is if you switch back and forth between next line and next, or next line and some of these other ones like next boolean, next int, you will sometimes have problems where we'll skip over one. So I'd recommend using against next line unless you're going to be using next line exclusively. So we'll say takes the entire line of text and say be careful using in combination with other dot nexts. So that explains how you use the scanner class to take user input from the console. Thanks for watching. If you enjoyed the video, please hit the like button and then leave me a comment down below. To see the next video, click on the image on the left side of the screen. To see the entire playlist for the series, click on the image on the right side of the screen. And to keep up to date on all the latest content, hit the subscribe button in the middle.